Good morning, children. How are you? I hope feeling well. Now, I am taking chapter 3 of your textbook, that is Understanding Quadrilaterals. In this chapter, firstly we have to know about polygons. Polygon, a simple closed figure made by only line segments, is called a polygon. A polygon is made by line segments and it must be closed. Suppose we are taking 3 line segments and closed figure will be obtained, that will give you a triangle, and you are having 4 line segments and a closed figure is formed, that is a quadrilateral. And similarly, if there are 5 line segments and we have to draw a polygon, that is called pentagon. Here triangle is the polygon with least number of sides. You may be asked a question that how many sides we can take at least to make a polygon. That means we have to take at least 3 line segments. Now, some definitions for quadrilateral. Quadrilateral, a polygon which is made of 4 line segments, is called a quadrilateral. That means it is a closed figure made by 4 line segments. It is called quadrilateral. And examples are rectangle, parallelogram, kite type figure, etc. Now, diagonals. In a quadrilateral which have 4 sides and more than 4 sides have their diagonals also. A diagonal is a line segment connecting two non-consecutive vertices of a polygon. Consecutive vertices means the vertices which are connected. According to this figure A, B, C, D, here A and B are consecutive vertices. B and C are consecutive vertices. A and D are consecutive vertices. So, non-consecutive are either A and C, means AC, or B to D, it means BD. It means a quadrilateral has two diagonals AC and BD. But in case of triangle, all vertices are consecutive. So a triangle has no diagonals. Now some definitions about convex polygon. A polygon with no portion of its diagonals here is some mistake in the spelling and some mistake is here. Polygon with no portion of its diagonal in their interiors, means if we draw the diagonal of a polygon, no portion of it may be outside of the polygon. The full diagonal should be within polygon. These kind of figures are like this. Rectangle, if we draw diagonal, both diagonal will lie within it. A pentagon, if we draw diagonals, all diagonals lie within it. And a parallelogram, If we draw its diagonals, all will lie within parallelogram. Now, what kind of figures are called concave polygons? Like star-like figure, and which, if we connect some diagonals of that figure, those will come outside of the figure. So these kind of figures are called concave polygons. A regular polygon is a polygon which has equal angles and equal number of sides. In equal sides, equal angle and equal side measure. Equilateral triangle, it has three sides, all sides are equal, and all angles are also equal. So it is a least regular polygon. A square, it is also having all sides equal and all angles equal 90 degree. Similarly, if a pentagon is there, it has all sides equal and all angles equal, it is called regular pentagon. And similarly for hexagon, it may be called regular hexagon if it has all angles equal and all sides equal. Now angle sum property is there. Angle sum of interior angles of a triangle is 180 degree. Angle sum of interior angles of a quadrilateral is 360 degree. How it is? If we have a quadrilateral, we divide it into two triangles, and we know that one triangle has angle sum 180 degree and another triangle will also have angle sum 180 degree. Then the total sum of the interior angles of a quadrilateral becomes 2 into 180 degree, that is 360 degree. Similar cases for pentagon, we connect diagonals and get three triangles within it, and each triangle has interior angle sum 180 degree. Then three triangles will have interior angle sum 3 into 180 degree, that is 540 degree. So angle sum of a pentagon is 540 degree. This is the method to find interior angle sum of a polygon. We can divide interior of a triangle into triangles, and thus we can get sum of interior angles of a polygon. There is a formula also. Angle sum of a polygon is n minus 2 into 180 degree. N means number of sides. If triangle is there, then the n is equal to 3. And if quadrilateral is there, n is equal to 4. And if pentagon is there, n is equal to 5. And thus, using this formula, we can get the angle sum by putting the value of n. Now some definition for curve. Simple curve, a non-intersecting curve or which does not cross itself, is called simple curve, like this. And one is open curve, another one is closed curve. Now convex quadrilateral, figure is deformed. In this diagonal will be within it, and if we draw this concave quadrilateral, this is concave, not convex, and if this side is connected here, we get its diagonal, one diagonal is outside of it. And angle sum, if we have to find, we get in both the cases two triangles. In convex quadrilateral as well as in concave quadrilateral. So the angle sum of the interior angles will equal to 2 into 180 degree, so that will give you 360 degree in both the cases. Now question number 5 is there for regular polygon. So 3 sides are there, it means all sides, and regular means all sides and all angles equals, so that will give you equilateral triangle. And in case of 4 side figure, regular figure will be square, and in 6 side figure, regular polygon will be regular hexagon. Now there is question number 6, in which a figure is there quadrilateral, and in which 3 angles are given, and you have to find fourth angle, that is x. So what can you do? We use the sum of the angles of a quadrilateral is equal to 360 degree. So adding all 50 plus 130 plus 120 plus x is equal to 360. Adding all, we get 300 plus x is equal to 360. That is give you x is equal to 360 minus 300, that is 60 degree. Thus you can use this in other questions also. And fourth question is there, whose one part is angle sum. How will you find the angle sum? As we know that angle sum of polygon is equal to n minus 2 into 180. That means if we have the value of n, we put here the value of n. Suppose value of n is 7 in the first part, that is a heptagon. So its angle sum will be equal to 7 minus 2 into 180. That means 5 into 180, that is 900 degree. Thus the heptagon has an interior angle sum 900 degree. And similar way you can solve the questions from your exercise 1, 2, 4 and 6. Thank you.